Welcome back, folks. In this video lecture, we'll talk about chapter number 2, and we will learn about the resultant forces. So, resultant forces. We'll learn how to find out the resultant forces by two methods. One is the triangle method, another is the component method. Component method. Now, first of all, I'll try to solve a question using the triangle method, and then later on, we'll try to solve the same question using the component method. So let's take an example from the book. I'm taking the question, it is example 2.4 on the book. So it has two vectors. One is 8 Newton. This is B vector given to me. Another vector given to me here is A equal to 6 Newton. I just want to tell you the example number may be different in your book, so don't worry about the example number. Try to understand this question, and then you can solve all the questions based on the concepts. So this angle given to me is 30 degrees. Another angle given to me here is 40 degrees. So first of all, we'll try to learn how to draw the vector triangle. Means this triangle we'll try to draw, and once we can draw the right means the correct one, the correct triangle, and then we'll be able to solve this question. So when we talk about the triangle method, we must make sure that the resultant vector and one of the vectors start from the 1 point. So what do I mean by that? So let's say this is one of the points, like this one. I'm drawing it here, and I'm going to take any one of the vectors. Right now I'm taking the vector number b. So this is vector b I've drawn, and this is my origin point. So my one of the vectors, which is vector b, which is starting from this point, and the other resultant vector must start from this point also. And now what we're going to do is, as I said, we wanted to complete the triangle. So this vector will start now from the tip of the vector we've already drawn. So that is the condition we must follow. So this is how the tail of the vector a will be at the tip of vector b. So this is vector a, and now the resultant vector will be drawn again from this origin point, and where it will end at the tip of vector a. And that's how we'll be able to complete the triangle. So we've completed the triangle, and now we just need to identify the angles and then solve this question. So this angle given to me here is 30 degrees, and this angle with horizontal is 40 degrees. So if I draw a horizontal line here, so this angle will also become 40 degrees, and this angle is 30 degrees, so this angle will also be 30 degrees. So this total angle will be 70 degrees. So I have the angle. Now I wanted to find the resultant vector, this one. And vector b is 8 Newton, vector a is 6 Newton. I can apply the cosine formula here. R equal to a square, or actually r square equal to a square plus b square plus or minus 2ab cos of alpha. Now, I will highly encourage you to go back and look into this formula, cosine formula. If you're not familiar with this, try to familiarize yourself with this, and then you'll be able to solve this question easily. One thing I wanted to tell you about this formula: whatever your resultant vector is, the angle opposite to that should be down here. So here, this is, I marked it as the resultant vector. This is the resultant, and the sides, two sides I've taken, two sides here, and then I've taken the angle opposite to whatever is on the left hand side here. Okay, so now we will just plug in the values. So this will be a is 6 square plus 8 square minus 2 times 8 times 6 cos of angle given to us is 70 degrees. Now if I solve this one, 36 plus 64 minus 96 times 0.342, and then that's going to give me r square value as 67.2, 67.2. And then I can find the r value from here. R value is square root of 67.2, which will come across as 8.2 Newton. Now we figured out the resultant value. Now I have to find the angle also, at what angle this is at. So we wanted to find this angle. If somehow I can find this angle, I'll sum the 30-degree plus this angle. That's going to give me the total angle for the resultant vector with respect to the horizontal line. So to find that this angle, I will use the sine law. Earlier I used the cosine law. This was the cosine law formula. Now sine law. The previous one was cosine law. All right. Now, if I were to do the sine law, I will use sine of given angle. Let's say this angle, I'll mark this one as alpha here. Sine of alpha, and the side opposite to that is A, which is 6 Newton, equal to, I'm gonna take this angle now. So if I'm taking 70-degree angle, so sine of 70 degrees divided by the side opposite to that is this one, resultant, that comes across as 8.2. Now I can do the cross multiplication and solve for the angle. So 8.2 times sine of alpha, which is equal to 6 times sine of 70 degrees, and then sine alpha equal to 6.7. Well, actually not 6.7, it's 6 times sine 70. 6 times sine 70 divided by 8.2, and alpha value will come across as, or before that, sine alpha will be 0.688, and alpha is sine inverse of 0.688. That's gonna give us angle theta alpha as 43.5 degrees. And if this angle comes out to be, alpha angle is 43.5 degrees, then this total angle will be 30 plus 43.5 degrees. So resultant value is 8.2 at an angle of 43 plus 30. 43.5 plus 30 is 73.5 degrees. 73.5 degrees with respect to the horizontal line. So this is how we've drawn. This is 73.5 degrees. All right. Now that's how you can solve this question using the triangle method. Another thing I wanted to tell you is you can also draw the triangle by taking the a vector as the original vector. So if this is the vector a vector, and then the b vector was somewhere here, so I'm going to replace this b vector up here. Draw, let me change the color of the pencil. So this is the b vector, and then again the resultant vector must start from the origin point from here, and this will be the resultant vector for me. And this is how you can also solve. This angle is 40 degrees, this angle here will be 40 degrees, and this angle, let me change the color one more time, this angle will be 30 degrees because B was at an angle of 30. So now we can pretty much solve this for the resultant, and it's going to give you the exactly same answer. Well, okay, so hopefully you were able to understand this question. Again, one more time, I'll just quickly want to tell you is the resultant should start from the origin point from where you're starting, and the second vector should start from the tip of the first vector. So the first vector we've taken as the red vector, so the green vector which I'm starting is starting from the tip of the first vector. All right, so these are the two conditions you must remember to draw the triangle and complete the triangle, and then you can apply the cosine law and sine law to find out the required things which you are asked to find out. All right, now we're going to try and solve the same question using the component method also. Component method. All right, so let's say one more time, I'm going to draw this diagram. So we are given, second, so we are given this angle as 30 degrees, and then this is 6 Newton, and this one is 8 Newton. Oops, 8 Newton, and I'm looking for the resultant vector. This is the resultant v. Oops, what I'm doing, I actually end up drawing the same diagram. So of the triangle method. So this is 8 Newton and this one is 6 Newton. 6 Newton. So this angle here is 40 degrees. Now I will find the components of B vector. So Bx and By we will try to find out. Bx is B cos of 30 degrees. By is B sine of 30 degrees. And these values will come across as 6.93 and B sine 30 is 4, and then I'll find ax and ay. Ax value will be a cos of 40 degrees. I can complete the triangle here, so I'll show you how I am doing. Again, if you're confused, always I'll recommend you to draw a right angle here so that you can see what you are doing. So this is a right angle triangle here, so this opposite side, so opposite upon hypotenuse, which is 8, opposite upon hypotenuse equal to sine theta, and opposite side in this case is what we are looking for. Opposite equal to hypotenuse, which is 8 times sine of 30 degrees, which will give you by. Same way bx value will be, if I were to do it here, it is equal to adjacent upon hypotenuse equal to cos theta. That's what we did. And then this goes on the other side. So adjacent side is equal to 8 times cos of 30 degrees. Same process we're going to apply for the ax and ay also. So here a cos of 40 degrees and other value will be a sine of 30 degrees. So this is a sine of 40 degrees, shall I say. So the value will come across as 4.6 and this value will come across as 3.85. And now I wanted to find net x. F net x, horizontal forces. What are the forces acting in the horizontal direction along this? This is the horizontal, right? So net x value will be F force, or I can write directly as a ax, which is in the negative direction. If I see the x component of this 6 Newton is in this direction to the left forces will take it as negative, and right forces will take it as positive. Up forces we will take as positive, and then down forces will take it as negative. Okay, so let me again change the color. So this component and this has 6 has an upward component. Same way this 8 Newton has one to the right, this one, and then one to the up. So these two components are up, so both are positive. This is left negative, this component of the b is positive. So a is negative, bx is positive, and that's gonna give you negative 4.6 plus bx is 6.93, which will be 2.33, and f net y, that is equal to ay plus by, and that comes across as 3.85 plus 4. Now that is 7.85. Now we have both the values. Now we'll draw the components again. So this is a positive number, so I'm going to keep it to the right hand side. This is also a positive number. I'm going to draw it in the upward direction. And then this is not the resultant. Please don't start drawing the resultant like this. Resultant will be outwards from the original point, or the origin point, shall I say. And this vector, I can replace it here because opposite sides of a rectangle are equal. So this side is equal to this side. All right, so the y is 7.85, 7.85, and this value is 2.33, and this angle is theta. Now I can apply the Pythagoras theorem. 2.33 square plus 7.85 square and square root. That's going to give me the resultant value. So resultant value will come across as 8.18. All right. which is same as 8.2, which we previously got. So approximately 8.2 newtons, and then angle is tangent theta, which is equal to opposite upon adjacent, and theta value will be tangent inverse. Opposite value in this case is 7.85 divided by 2.33, and the theta angle will come across as 73.5 degrees approximately. All right, so hopefully you were able to understand how to simplify these questions. I'll see you with another video. Till then, goodbye.